Okay, for this lesson, we're going to continue taking a look at solving absolute value equations. Now, what's unique about this is, in this case, we're going to include two absolute values in the same equation. If I have two absolute values, then I have two x-intercepts that would occur from each absolute value, which would mean that those are points where my graph or my line should turn. So I'm going to graph out my left-hand side, just like we were doing in the last case, and say that y1 is equal to the absolute value of 2x minus 3 minus the absolute value of x plus 4. And when I graph that into my calculator, I'm going to get something that looks approximately like this. I can see that there's two turning points that occur, and those both occur on the x-intercepts, or the zeros, of the absolute values. I'm going to put in my second equation, where y2 is equal to 8. And then I'm going to solve for where those intersect. So I have one that should be intersecting right about here, and another one that should be intersecting right about here. This one occurs at 15 and 8, and this one occurs at -3 and 8. Which means that x would equal either -3 or 15. All right, let's take a look at how to do this algebraically. So I know that there's going to be two turning points that would occur at if one of the absolute values or the other absolute value is equal to 0. If I took the 2x minus 3 is equal to 0, then that gives me 3 over 2. If I take the x plus 4, that would be at the minus 4. And we can see that right over here. We know that when it's to the left of the -4, because of our piecewise function, that this is going to be negative. We know that when it's to the right of that -4, this would be the positive version. So we can write right away that in the first section, less than -4, that x plus 4 is going to be negative. In the second section, it's going to be positive. Positive x plus 4. We know that this is going to be positive when it is greater than 3 over 2. And we know that it's going to be negative when it is less than 3 over 2. And because -4 is also less than 3 over 2, I'm still going to get that negative version of it over here. Same thing, because I know that the positive version of x plus 4 is occurring here, if I keep going bigger, it's still going to be the positive version of x plus 4. It's still bigger than negative 4. So that's how I can figure out if it's positive or negative in each domain. Only one of the absolute values should change at each of the changing point, and it's just the absolute value that is related to that domain. The first one, they've already solved for us. The first one, they went through and said, well, this one's negative and this one's negative. Went through the process of solving it to get -1, and -1 is not less than -4, so we know that this one doesn't work. When we go to the next domain, then we know that the 2x minus 3 is still negative. We know that the x plus 4 is positive, and it's still equal to 8. So I'm going to wind up with negative 2x plus 3 minus x minus 4 is equal to 8. I combine my x's and I have negative 3x's. I'm going to move my constants to the other side by adding 4 and subtracting 3 to get 9. And x would equal negative 3. Is this in the subdomain? Does this exist between -4 and positive 3 over 2? Yes. So that is one of the solutions. When I get to the last domain, they're both positive. So now I'm going to have positive 2x minus 3 minus the positive x plus 4. And that's going to equal 8. And now I can say that 2x minus 3 minus x minus 4 is equal to 8. I combine my x's to get a singular x. I'm going to add 4 and add 3 to both sides to get 15. Is a solution in the subdomain? Yes. And that's where my other solution comes from. So when I go back and look at my graph, I can see that there is a solution between the two changing points occurring here and here. And there is a solution in the top domain, which matches what we just found. When we go to this last example, same process. I'm going to say that from this one, I have a domain where it's less than 4. From this one, it changes at 2. So it can either occur where it is less than the smaller x value, where it is between the two, or where it is greater than the bigger x value. In the top region, they're both positive. In the middle region, or going from here to here, we can see that the x minus 2 becomes negative. But the x plus 4 is still positive. It hasn't changed yet. And then we go through the next region. It's the x plus 4 changes, and they're both going to be negative. Negative x minus 4 and negative x plus 2. I'm going to solve each case. So here I have positive x plus 4 is equal to negative x plus 2. I'm going to move the x's to one side to get 2x. I'm going to subtract 4 from each side and get negative 2. And x, when I divide both sides by 2, would equal negative 1. Does negative 1 exist between negative 4 and 2? Yes. It's in the subdomain. So negative 1 is a possible answer. When I go through the bottom domain, negative x minus 4 is equal to negative x plus 2. When I add an x to both sides, then negative 4 is equal to 2. But we know that that's not possible. The x's cancel each other out, which means that no solution in this region. And the only possible answer is that x is equal to negative 1. All right, go try some practice.